Ally PLM.
Hello and good afternoon. My name is Kyle Bentley. I'm an application engineer with Ally PLM Solutions. I'd like to thank you for joining our NX CAD Lunch Byte series. For those of you that aren't familiar with our Lunch Bytes, these are features and commands that are sometimes overlooked. Today's topic we're going to cover is convergent modeling, a new paradigm that was introduced inside NX 11. So let's go ahead and look at the agenda to familiarize ourselves on the topics we are going to cover. First, we need to establish what convergent modeling actually is, then why we should use convergent modeling and how it is used. Also look at some problems previously working with facet data and how we can fix these problems with convergent modeling, creating geometry directly on the facet, perform Boolean operations such as unite and subtract with facet data to help receive our final design, and also directly subtracting and cutting the facet. So what is convergent modeling exactly? Convergent modeling works with facets, surfaces, and solids without any conversion. This allows for geometry to be created around or on the facet. Boolean operations can be performed on the facet to help receive the actual design quicker. So why use convergent modeling? Facets, such as STL files that we're going to be looking at today, are the format of choice for fast-moving technologies. Gaming, for example, uses these facets for model representations inside the actual game. Virtual reality also uses facets for model representations. Referring to reverse engineering, medical, aerospace, and automotive will use some form of scanner in the field to output the facet data that we will be using. Then once we have our part designed in context with the facet, we can use additive machining capabilities with our facet. Using reverse engineering, the medical industry uses body scanners to output their desired component. Here showing a skull that we will use in our actual examples. Aftermarket companies in the automotive industry use scanners on actual cars to output their desired component to create enhanced designs to sell for their company. Here showing a front bumper of a high-end car. Aerospace also uses scanners in the field on the actual component, just like automotive would. Aerospace companies will use the facet for modifications for new engines, or if the original files have been corrupt, scanners and facets can be used to help generate the new component. So how is convergent modeling used? Medical, for example, uses data from scanners to output their desired facet. Then, they can create custom fit designs on that facet, such as patches, hearing aids, and braces for broken bones. We can also use this facet to design replacement parts, such as bones. Automotive and aerospace will use scanners out in the field to output their component. We can then use these components to design repaired parts, use them for diagnostics and modifications. All of these examples have additive machining capabilities to 3D print. So let's look at some previous problems working with facets. Facets have to be converted into surfaces and solids to support our modeling operations. Reverse engineering workflows that were in place to make the conversion are often slow and complex that require skill to acquire an actual usable result. With convergent modeling, however, there is no need for a conversion. We can directly interact with the facet quickly and efficiently, unlike before. So here you see the STL file of the skull that I showed in the examples before, and a patch that has been created directly on the surface of the facet. So here, after we have the original patch created, we will develop a quick change and a pattern on our patch to display some changes. So let's go ahead and look at NX now. So now with NX 11 actually open, the first thing we need to do is go ahead and import our skull. So now I'll go ahead and import my STL file, and we'll go ahead and select the STL file here, this being the skull. So now for the facet body output type, we need to make sure that this is on convergent. This is what makes convergent modeling actually possible in NX 11. So now when you go ahead and press OK, you'll notice that the skull is then imported into the file. So then the first thing we need to do is go ahead and create a sketch for our patch. So now I'll go ahead and create a sketch on that front plane. So from here, this is just like any other sketch inside NX. We can constrain this sketch as needed. For this sketch, I'm going to go ahead and use the Studio spline, and we can pull these points as needed for desired size. So now with that sketch actually created, I need to go ahead and divide that sketch with the surface of the skull. So now I'm going to go ahead and use the divide face command. And what the divide face command is going to do, it's going to project that sketch onto the outside surface normal to where we created our sketch plane. So now I'm going to go ahead and select my skull and then select my sketch. And now you'll notice that that sketch is actually projected onto the outside surface of that skull and actually taking the curvature of that skull also. So now with that subdivided sketch actually created, we need to go ahead and extrude that subdivided sketch. So now we can go ahead and select that subdivided sketch to extrude it. And from here you notice that it's actually going the wrong direction, so we need to go ahead and reverse that direction. And this is just like any other extrusion inside NX. We can pull the vector for desired size, or we can go ahead and type in a value. From here I'm going to go ahead and type in 1.5 millimeters for my value, and I'm going to leave the Boolean on none. So now with the original patch created, we're going to look at making a quick change. I'm going to make it just a little bit larger than the original patch here. So from here, I'm going to use the offset face command, and I'm going to go ahead and offset this face just a little bit larger than the original size here. And this will make it 1.5 millimeters larger than the original patch. So now that we have our patch to desired size, we need to go ahead and create our pattern. So now we'll go ahead and create a sketch for our pattern. And we're going to go ahead and create the sketch on the front plane again. So with this pattern, we're going to go ahead and use a 3 millimeter circle somewhere in the middle of that patch. And we're going to use it based on the border of that patch that we actually created. So now you notice when I actually finish that sketch, we can't actually see that sketch right now. So now the first thing that we need to do before we get into the pattern is we need to change the transparency of the patch and the skull. So now I'll go ahead and select both the skull and the patch. And we'll change the transparency to about 50%. So now you notice we can actually see that sketch through the patch and the skull. So now the next thing we need to do is go ahead and show the outside border of that patch. So we're going to go ahead and show the original sketch that we created for that patch. So now we can go ahead and use our pattern. So now I can go ahead and select the circle that I created. And then we're going to use a boundary curve being our border for our linear pattern. So now I'm going to go ahead and select the outside border here. So now you'll notice it actually creates that pattern based on the boundary I selected. And now I have some parameters set here. For the layout, I have selected diamond. And we can change this as needed if we wanted to. I'm going to leave it on diamond for now. And the pitch distance I have is 8 millimeters. So now I'm going to go ahead and press OK. So with that pattern actually created, I need to go ahead and extrude cut through my patch. So now I'm going to go ahead and select my pattern. And now I'm going to go ahead and pull it through my patch. And now we need to go ahead and subtract that material from that patch. . 。  . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . So now with the patch created, let's go ahead and change the color of the patch so it's a different color from the skull. So now I'll go ahead and select that patch. But first, let's go ahead and change the transparency to 0, and then change the color so it's a different color from the patch. So that is how we would create geometry directly on the facet. This prevents us from performing a complex conversion on the facet. So now we're going to look at Boolean operations. Boolean operations using facets to help output our desired design result. The first application we are going to look at is a subtract. The first example for subtract we are going to look at uses the design component and facet body to output our desired design result. The second example for subtract we are going to take a look at uses a design component and a bitmap that has been converted into a facet to help create complex geometry. Another Boolean operation known as unite, we're going to look at two components that have been scanned in from the field that are missing material. We will then locate these components back to the original position, create a patch over the missing material, and then unite the body as one solid body. So here, our first Boolean operation being a subtract, we'll use the design component, this being a brace for the medical field to modify the bone, and the facet data of a knee. We will then use the Boolean subtract to cut away the extra material on the component colliding with the facet. So here, this being the finished component after the material has been cut away from the facet to mount onto the knee. So now let's go ahead and take a look at NX. So here with the STL file already imported in, this being the knee I just showed, we need to go ahead and show the brace. So now with that brace actually shown, this was designed around the knee. But to custom fit this knee, we need to subtract the extra material right here. So now we're going to go ahead and do a simple subtract Boolean. So now I'll go ahead and select my component, and then select the STL file. And now when you go ahead and press OK, you'll notice that it actually subtracts away that extra material. So this is how we can quickly and easily output custom designs using just a subtract to create custom components in just seconds. So the next Boolean subtract example we're going to look at uses the design component and a bitmap file that's been converted into a facet. We will then use the Boolean subtract to output complex geometry. So here you'll notice that there has been a key grip section that has been created, and also when subtracting with the bitmap file, you'll notice this outputs complex geometry. So now let's go ahead and take a look at NX. So now with NX11 actually open, you'll notice that I have the key already designed. But notice that the key grip section hasn't already been developed. So we need to go ahead and show my tool body that I have created here. And we're going to do a simple subtract just like our example before, but this time we're going to use two components instead of using an STL file. So now I'll go ahead and select my key and then my tool body. So notice that it actually puts the key grip section in there, but there isn't any complex geometry from a bitmap file. So now we're going to go ahead and look at the bitmap file before we actually trim our tool body and then do a subtract to implement it into our key. So the first thing we need to do is go ahead and show our bitmap file that's been converted into a facet. So now I'll go ahead and press show. So here you notice that it actually isn't on the key just yet, but this is the bitmap file that we're going to be using. Here I'll go ahead and hide the key so we can see the bitmap file even better. So this is the complex geometry that we're going to be putting in that key grips section. So now I'll go ahead and show back my key. And now I'm going to go ahead and hide that bitmap file. So the first thing I need to do is go ahead and delete my subtract. Now we're going to go ahead and use a trim, and we're going to trim that bitmap file with our tool body. So that way when we do the subtract, it will implement that complex geometry onto the key grip section. So now we need to go ahead and go up to our trim. So now we're going to go ahead and select our tool body, and then we need to go ahead and select our bitmap file. So now we'll go ahead and press OK. So now with the tool body actually trimmed with our bitmap file, we need to go ahead and show our tool body. And now we can go ahead and do our subtract. So now I'll go ahead and select my tool body. To subtract from. So now as you can see, it's not actually going to update automatically. We have to press OK for it to update. But when we press OK, you'll notice that the geometry is then implemented into that key grip section. This geometry would actually be very difficult to design with ordinary operations. So now let's go ahead and look at possibly making a change to that bitmap or changing that bitmap file. So now we need to go ahead and edit back into the trim body. So now inside the trim body command, we can go ahead and deselect the original bitmap file that we selected. And now we can go ahead and select a new bitmap file that we already have in this file. So now we'll go ahead and select a new bitmap file. And now we'll go ahead and press OK. So here you'll now see that the bitmap has updated and placed even more complex geometry of a gorilla's face that would almost be impossible to model with ordinary modeling tools. This is another great way to perform a subtract to output complex geometry. So the last Boolean application we're going to look at is a unite. Here we have two components that have been scanned in from the field to make a repair. In the picture below, you'll notice I have already moved them in context with one another to their original position. From there, you'll notice that we are missing material from the parts that have been scanned in from the field. So we will then create a patch and unite the bodies together as shown here to create one solid component. So now let's go ahead and take a look at NX. So now with NX open, we need to go ahead and import our STL files. So now I'll go ahead and go to Import, select our STL, and now I'll go ahead and select my first STL file. Make sure our facet body output type is on Convergent, and hit Apply so the dialog stays up. So now that my dialog is still up, I can go ahead and select my other STL file to import. So I'll go ahead and select my second STL file. Make sure the facet body output type again is on Convergent, and then press OK to accept that dialog and import my second component in. So now you'll notice that both these components actually aren't in context with one another and to their original position. So now we need to go ahead and use the NX measuring tools to figure out the distance we need to move them back to their original position. So now I'll use the measure distance. And first I'm going to go ahead and find the X direction. So now I'll select my first face and my first component, and then my second component here. So the X direction is 55 millimeters. So now we need to go ahead and find the Y direction now. I'll select my first face and my first component, and then select my second component, and we get 65 millimeters. So now that we know the distances to move them back to the original position, I need to go ahead and use the move object command to move them back to the original position. So now I'll go ahead and select my object here, and then I'm going to go ahead and move it in the X direction first. So I'm going to go ahead and select my X vector. From here you notice that it's actually going in the opposite direction of where I want it to go. So I'm going to go ahead and type in a negative value, and then the 55 we found with the NX measuring tools. So now I need to go ahead and move it in the Y direction now. So now I'll select my Y vector. Again, it's actually going in the negative direction. So now I need to go ahead and type in a negative value, and then the 65 we found using the NX measuring tools again, and then go ahead and press OK. So from here, moving them back to the original position, we're actually missing material. So from here we're going to go ahead and create a patch over that missing material and then extrude it to the same thickness as those parts. So the first thing I need to do is go ahead and create a sketch on that top surface of these components. So now I need to go ahead and specify the orientation of my coordinate system for my sketch. So now with the coordinate system defined, I can quickly and easily draw over that missing material So now with the sketch actually created, we need to go ahead and extrude that rectangle to the same thickness as those parts. So now I'll go ahead and select that rectangle. And it was actually going in the wrong direction, so I went ahead and reversed it. So now inside the extrude command, I can actually use the NX measuring tools to find the exact thickness of those parts. So now we're actually going to be using the Z-axis this time. So I'm going to select the top and the bottom surface now, and it will give me the exact thickness to extrude to. So now I'll go ahead and press OK. You can actually see here that it will actually put it in the extrude for me. So now for the Boolean, I want it to be none. So now we'll go ahead and press OK. So from here we actually need to unite these bodies all in one so we have one solid component. So now I'll go up to my Boolean operations and select my first body in the patch to unite. Notice it says it's going to be a convergent body. And then I'm going to go ahead and select my last body to unite to. And that will make one solid component. So this is how we can make repairs to components that need material filled in if we don't have the original drawings and models to use. So the last example on our agenda is looking at subtracting material from the facet itself. Notice in the skull to the right, which is what we are going to take a look at, how to cut a hole through the skull or any STL file. The picture on the left shows a cutout and a jackalope of an eye socket. So here you notice that you can subtract material from the STL file and then add material as needed as shown earlier in the lunch bite. For this demonstration, I'm going to show how to cut a hole through a skull. So let's go ahead and take a look at NX now. So with NX open now, we need to go ahead and import our skull. So now I'll select STL, and now I'll go ahead and import my STL, this being the skull. Make sure our facet body output type is on Convergent here, and then go ahead and press OK. So from here, our skull is then imported into the file just like earlier. So now we need to go ahead and create a sketch for our cutout. So we'll go ahead and create it on the front plane. So now I'm going to go ahead and do a circular cutout. I'm going to use a circle for this cutout and draw somewhere in about the middle of the skull, and then draw a 5mm diameter circle to cut through both sides of the skull. And then we're going to go ahead and extrude cut that circle. And I want it to be on both sides, so I'll use the symmetric value. And now I'm going to go ahead and pull it straight through the skull on both sides. And now, actually, inside the extrude command, we can do our Boolean operations, such as subtract. So now we'll go ahead and press OK. So this is just one simple way on how to subtract material directly from the facet itself. So for more information on convergent modeling in NX 11, you can use the NX help documentation inside NX 11 if you have it set up. If you don't have help set up, the documentation link is below. So that's all I have for convergent modeling. If you want to see other NX CAD lunch bites or other great information on NX CAD, please go to our website and go to the Resources tab. So for our Ally PLM NX training classes, we have Essentials for NX Designers, which is 5 days, Advanced Techniques for NX Designers, which is 4 days, NX CAM Fundamentals, which is 5 days, NX CAM Advanced Techniques, which is 5 days, NX CAM Turning Fundamentals, which is 2 days, and we also do NX version updates for CAD and CAM. And remember, all of our classes can be taught online. So thanks for your time. If you have any questions or concerns about convergent modeling, leave a comment below or feel free to contact me directly. Once again, thanks for your time and have a great day.
Ally PLM.